All right, so we might as well go ahead and prove this one. Okay, so what if we let y equals f of x, which means that f inverse of y equals f inverse of f of x. Okay, so we already showed that the inverse and the function kind of cancel each other out. So that means that f inverse of y is equal to x. Okay, so what if for y equals f of x we pick some point, let's say y of 0 equals f of x 0. Okay, so we have those two. And let's say if we pick some point for the inverse, f inverse of y0 equals x0. Okay, so we know that the limit, let me go ahead and write that out. F inverse prime of x, well, let's say y0, since we're picking a specific point. Is equal to the limit as y approaches y0 of f inverse of x plus 8, because remember we're just going from y to y0, minus f inverse of y0 all over y minus y0. Okay, which is equal to, we already know that y is equal to, where is it, f of x. So that gives us the limit as y approaches y0 of f inverse of f of x. y0, we know that's f of x0. F inverse, there we go, f of x0 all over y, which is f of x, minus y0, which is f of x0. Okay. So we already know that the inverse and the function kind of cancel each other out. So here we end up with x, minus here we'll end up with x0 all over f of x minus f of x0. Okay, so we're no longer dealing with a limit with the variables y, so in this case it's now as x approaches x0. Okay, so if you look at this, it's kind of a reciprocal of a function of x. Okay, so it's kind of like 1 over f prime of x0. Okay, so it's just reciprocal kind, I mean the derivative kind of flipped. Instead of f of x minus f of x0 over x minus x0, it's just flipped. Okay, so we know our x0, where'd it go? Where'd it go? Where'd it go? Ah, here we go. Is equal to f inverse of y0. So we have 1 over the derivative of f inverse at some point y0, which gives us our original formula. All right, so any questions on that one? All right, let's do a couple of examples. Right, looks like everyone's done. Okay, so let's say, for example, if you wanted to find f inverse prime of -7, oh, that looks like another one. When f of x is equal to 3x to the third plus x squared plus x minus 12. And we're given that f of 1 equals negative 7. All right. So probably the most important part of this problem is the given. Okay? Simply because if we know that f of 1 is equal to negative 7, if we apply f inverse to both sides, f inverse of f of 1 equals f inverse of negative 7. So that gives us f inverse of negative 7. Remember, those two kind of cancel each other out. Equals 1. Okay. Now, it doesn't give us f inverse prime, just give us f inverse. Okay. But we do know that f inverse prime of negative 7, just using the formula, is going to equal 1. Let me kind of separate that a little bit. Over f prime of f inverse of 7. Okay. We already know f inverse of 7 is 1. So that means it's going to equal 1 over f prime of 1. Okay. So really now all we have to do is just find f prime of 1. Okay. So we know f of x is 3x to the third plus x squared plus x minus 12. So f prime of x is going to equal, bring down our 3, so we have 9x squared, plus, bring down our 2, 2x, plus 1. Okay. So f prime of 1, we just go ahead and plug it in. 9 times 1 squared plus 2 times 1 plus 1. Let's have 9 plus 2 plus 1. So that means f prime of 1 is going to equal 12. Okay. So we know just from here, you don't have to rewrite all this every time, but I'm just kind of going through the steps. Oh, move that up a little bit. F inverse prime of negative 7. We figured out that that's 1 over f prime of 1. So we know that's just 1 over 12. All right. So any questions on that one? All right. Bring it down a bit. All right. Okay, let's say, for example, we want to find, say, t inverse prime of negative 8. Uh-oh. For t of x is equal to negative x to the third minus 8x, minus 8. Given that t of 0 is equal to negative 8. Okay, so just like before, we're going to start with what was given to us. Okay, so we know if t of 0 is equal to -8. And we apply T inverse to both sides. We have T inverse, T of 0 equals T inverse of -8. These two, of course, kind of cancel each other out. So you have T inverse of -8 is equal to 0. Okay. So going to our formula, T inverse prime of -8 is going to equal 1 over T prime of T inverse of -8. Okay. So you already know our T inverse of -8, it's 0. So T prime of 0. So now all we have to do is find T prime of 0. Straighten that up just here. There we go. Okay. So our T prime of x is equal to, bring down our 3, so have -3x squared. The derivative of x is just 1, so that's -8. Derivative of a constant is just 0, so that last 8 kind of disappears. Okay. So our T prime of 0 is equal to -3 times 0 squared, -8, which is just -8. Okay, so kind of just recapping everything. Our T inverse prime of -8, we know that's 1 over T prime of 0, which is just -1 over 8. Move that over a little bit. All right. So any questions on that one? All right. Okay, so we'll do one more example, then we'll move on to the next item. Everyone's still writing. I'll leave it up for a few more seconds. Let's clean that up a little. All right. Okay, so let's say that I want to find, say, y inverse prime of -3 for y of x equal to 5x plus 2 over -2x plus 1. If we're given that y of 5 is equal to -3. Okay, so just like before, we're going to start with what we were given. Y of 5 equals -3. Apply y inverse to both sides. So y inverse of y of 5 equals y inverse of -3. And we know the function and the inverse kind of cancel each other out. So we know y inverse of -3 is equal to 5. Okay, so that means using our formula, y inverse prime negative 3 is going to equal 1 over the derivative of the inverse. Okay, we know y inverse of negative 3. Move that over just a little more. There we go. There we go. So we already know y inverse of negative 3 is equal to 5, so that's 1 over y prime of 5, which means we just have to find our y prime of 5. All right. So y prime of x, since it's a quotient, you have to use the quotient rule. The denominator, negative 2x plus 1, times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Okay, so that gives us negative 2x plus 1 times the derivative of 5x plus 2 is just 5, since the 2 disappears, minus 5x plus 2 times the derivative of negative 2x plus 1, it just becomes negative 2, all over negative 2x plus 1 squared. Okay, so this negative and negative makes that a positive, so we can go ahead and distribute those. Okay, so that's going to equal negative 10x plus 5. That becomes plus 10x plus 4, all over negative 2x plus 1 squared. Okay, so the negative 10x and 10x cancel each other out. That just becomes 0. So that disappears. And we can go ahead and add those two together. So we know our y prime of x is equal to 9 over negative 2x plus 1 squared. Okay, so we don't need y prime of x, we need y prime of 5. So that means that y prime of 5, move that up a little bit, is just equal to 9 over negative 2 times 5 plus 1 squared. Okay, so negative 2 times 5 is negative 10, plus 1 is negative 9. So negative 9 squared is 81. We have 9 over 81, which simplifies to 1/9. Okay, so just recapping what we have up here, y inverse prime of negative 3, we already figured that was 1 over y prime of 5, which is equal to 1 over 1/9, which just becomes 9. All right, so any questions on that one? All right. Should have one see, I did. I must have left it on the desk. Be back in 2 minutes because this example's kind of important. Right, so okay, so you want to remember the graphs. And let's say if we go for sine of x. Say y equals cosine of x. And it looks, give or take, something like that. Okay, and y equals tangent of x. Okay, so we know tangent x is equal to sine over cosine, so we know cosine can never equal 0. That means x can't equal pi over 2 or negative pi over 2. So we have our asymptotes there. And tangent of x kind of looks like that, give or take. Okay, so if we have cosecant of x, we have x and we have y. So we have y equals cosecant of x. And remember, cosecant of x is just 1 over sine of x. Okay, so we know sine of x can't equal 0. Okay, so sine of x equals 0 at 0, pi, 2 pi, 3 pi, negative 2 pi, all of those. Okay, so we know it can't equal pi, can't equal 2 pi, can't equal 0. negative pi, so forth and so on. Okay. So we have our asymptotes there. Okay. So we know if sine kind of looks like there, and then it goes to there. We know that cosecant is the reciprocal, so the actual graph of cosecant is just flipped between there, so it kind of looks like that, and kind of looks like that. And then just keeps repeating over and over and over. Oh, that's pi. Okay, so we do the same thing for secant. Okay, so remember y equals secant. I may have to move that up a little bit. We know that secant of x is equal to 1 over cosine. Okay, so that means our cosine of x can't equal 0, which means it can't be 1 pi over 2, 3 pi over 2, 5 pi over 2, etc., and so on and so forth. And let me move this out the way. Okay, so we have our pi over 2, negative pi over 2, and stretch it out to 3 pi over 2. Okay, so we know it can't equal those. All right, so just like we did with cosecant, we know that if cosine kind of looks like that, move that out the way for now. Then we know the reciprocal of cosine, which is secant, is just flipped. Okay, so it goes like that. This kind of flips that way, and this one kind of flips like that. Okay, so this is our y equals, I'll move it over here, secant of x. Secant of x is just 1 over cosine. Okay, and really for cotangent, that's just tangent flipped around. Okay, so we have our x and our y. Okay, so we know that for y equals cotangent of x, cotangent of x is just 1 over tangent, or you can just say cosine of x over sine of x. Okay, which means sine of x can't equal 0. So we know that x can't equal 0, pi, 2 pi, 3 pi, etc., and so on. Okay, so we have pi, 2 pi, or even negative pi. Okay, so we know those are asymptotes. Okay, and it can't equal 0, so that's an asymptote also. But we know with tangent and cotangent, they're just kind of reciprocals of each other. So really, our cotangent is just tangent flipped around. Okay, so it kind of looks like that. And it repeats over and over and over